Hello, how you doing? This question here, it appeared. I found this from past paper from MIT questions, calculus, and also the same question appear in Cambridge exam. So let's do it. So very interesting question. Watch this question. Watch how I'm gonna break it. So this is tan substitution. This is a tricky substitution because whenever you have a root and you have x squared plus a squared, and then this is tan substitution. So first I'm gonna have to make this as a square. So when you say 2 and square root of 2 squared, the same thing, same as 2. So I'm gonna rearrange, I'm gonna rewrite it and say this is say integral x squared, and this will be x squared plus 2 square root and then square. There's no difference. It's the same thing. You see what I'm saying? Same thing. So then I'm gonna say we have a root here. I'll let x equal to square root of 2 with no square, right? And then tan of theta. The next thing, differentiate here, this is going to give you dx, and then when you differentiate, this is going to give you 2. When you differentiate tan, you get sec square theta d theta. So the next step, substitute everything back. Now we're going to say it's going to become integral x squared. This is x. X squared means this is going to become 2, and this is going to be tan squared. And then we over x square root of 2. But x squared means it's going to be square root of 2 square, which is like a 2, and then tan square plus square root of 2 square, and then now we go dx. What is the dx? Dx equal to square root of 2 and then sec square theta d theta. You see what I'm saying? So some of the stuff they're going to cancel. This one here equal to square root of 2 sec. So this is going to give us square root of 2 sec. I believe you understand. This is going to be square root of 2 sec, or if you don't know, you can just do slowly. Say this is going to be square root of 2. Square root of 2 square equal to 2. And then we have a tan square theta. And the same thing here is going to be plus 2. They have a root. So I can take 2 out. And then here I'm going to let you square root of tan plus 1. This is equal to sec. That's what I say. This all is going to give you square root of 2 sec. See? So this will become square root of 2 sec at the denominator. So this will become integral. We have 2 tan square root of 2 sec square. This denominator is going to be square root of 2 sec. So some of the expressions are going to cancel here. Square root of 2, square root of cancels. 1 sec and 1 sec cancel. So we're going to be left with here integral. 2 can just go to the back, and here it's going to be tan. Okay, 1 sec. So we come there to the top. So I can replace this. What is tan square? Tan square equal to sec square minus 1. Sec square minus 1. If you don't know, I can take you back just a second for the people who don't know. Look, we know sine square. This is a base way of, remember, equal to 1. How do you get tan? You get tan means it must be sine over cos. So this sine over cos. But everything then divided by cos square. So this and this is going to give us tan. And this is going to be 1 equal to 1 over cos equal to 1 over cos equal to sec square. That's why I say tan square equal to sec square minus 1, because this one can go over. So this one we can replace and say this equal to, we have a 2 out. See, and then tan square equal to sec square minus 1. And here we have it, sec theta d theta. So the next thing, multiply that out. When you multiply that out, this is going to become sec cube. So we have a 2, sorry, 2, just a 2, okay? And this is going to become sec cube. So we have integral sec cube theta, and then this one here is going to become minus sec theta. All this d theta. So I can separate this. So if I separate this, it's going to become 2. Okay, let's put integral is going to be integral of sec cube theta d theta minus integral sec theta, integral of sec theta d theta. So now this one no. So now I just have to finish this and the question is going to be finished. So I can put the 2 in, 2 here is going to be 2 and 2 here. So I'm going to remove this, I'll say 2 and then this is going to become 2 and then no more 2 outside. But this one here, no. See what I'm saying? So if I get done with this, then the question is going to be oh. So now I'm going to say, let me take this one here and integrate. This one I know equal to 2. Okay. Integral of sec equal to ln sec and tan. Okay, let's just do minus 2 ln of sec theta plus tan theta. Absolute. Oh, that's very small. Let me write big a little bit. So this one I will show you how to get. But the other part I know. This equal to 2. When you integrate sec theta, you get ln. Okay. You get what? Ln absolute sec theta plus tan theta. See, now let's deal with this one now. So we got 2 multiplied by something. Let's integrate that. See, so I'm gonna raise this so we can have space. Oh, I can just do it here. I think it can be enough. Okay. I doubt. So I'm gonna raise this part here. Let's just go. If the space no be enough, then we do. Okay. So integral of sec cube. When you say integral of sec cube, let me say integral of sec theta, and then sec square theta d theta. So you can just integrate this by parts. I'm taking this right in the integrate by parts. So this is going to be u by parts. This is going to be u. So u equal to sec theta, and then dv equal to sec square theta d theta. Differentiate u. It's going to give us du. And sec, when you differentiate, you're going to get what? Sec tan. Sec theta, tan theta. But here, when you integrate, you get v. And then when you integrate sec square, it's going to be like this. Look. When you integrate sec square, you get tan theta. So what we're going to do? Plugging in by parts, integration by parts or formula. So then we're going to have, let me see, okay, so we're going to have integral of sec cube theta d theta equal to, see, equal to, now we're going to say uv. What is a u? Sec and tan. So we can say sec theta tan theta minus integral of v. What is a v? Tan theta times du. We know by parts. What is a du? Sec theta tan theta. So this tan is going to become square and then sec theta d theta. See what I'm saying? And I believe you know how to do integration by parts. So I'm just doing straight away. So which is formula say this. But let me write here inside. Integral u dv equal to uv integral v du. You see what I'm saying? So u dv uv, that's to say u times our v. This one times that one, which is this one, minus integral v. What is a v? V was this one, tan theta, and then multiplied by du. What is a du? Sec theta, tan theta. Tan, and that tan make tan square, because this times this. Look, v times du. V times du. V is tan theta times tan theta equal to tan theta square times sec theta. Just in case for the people don't know. So now we have them. See? So what we're gonna do? What is tan square? Tan square equal to sec square minus 1. From the identity, tan square equal to sec square minus 1. So this is let me say integral of bracket tan square equal to sec square minus 1. Sec square theta minus 1. And then here we have sec theta d theta. So we can open the bracket. Okay. Now, and here we have a sec theta tan theta equal to sec cube. See, so I can just erase here. So I'm gonna have to erase here to have some space. I'm not gonna erase everything, just some of the stuff. Okay, got integral of sec cube theta d theta equal to that. So I can multiply this out. This is going to be sec cube, and this is going to be negative sec. So this same as say sec cube, because you multiply, this is going to be negative sec. Okay, so I can just say integral sec cube theta minus sec theta, like this. You see? So now I can open the bracket. So this is going to be minus and that's going to be plus. So then I'm going to have them right here. It's going to be integral of sec cube theta d theta equal to sec tan theta minus integral of sec cube d theta. You understand what I'm saying? And this is going to become plus integral of sec theta. Going to be plus integral of sec theta. So what happened? These and these are like terms, so I can just simply check these to the left. So integral sec cube, integral sec. So there's going to be two of them. 2 of integral of sec cube equal, because this is negative. When it comes, it's going to become. So 2 of them, they're going to become 2 of them. Equal to sec theta, tan theta, and this is going to become, when you integrate this, you're going to get ln absolute sec theta plus tan theta absolute. Okay, so now we come back here. We can eliminate, because look, 2 sec cube, so 2 sec cube equal to this. So I can simply take this expression and plug in here. Look, 2 sec cube equal to that, so plug in here. So then we're going to continue now in here. I'm going to say then it follow, then, or you can say substitute back, so you can just probably give this star equation. So you can say sub into star equation. So if you sub in the star equation, it follow that. It's going to become what? All of this equal to that, which is sec theta tan theta plus what? Ln sec plus tan, and then minus this one, 2 whatever, minus what? 2 ln sec plus tan theta. So what I'm saying? But a plus and minus, this is similar term. Look, ln sec tan minus 2 ln sec tan means it's going to give you negative ln sec tan. It's like 1x minus 2x. See? So these two, they're going to give us what? Minus what? Ln sec angle plus tan angle. And this is going to become sec theta tan theta. So for that case now, excuse me, let me do this. So for that case now, the question is finished, but it's not finished, because in the equation they give us term of x. So we have to eliminate these theta, and then it has to go back to x. So I can just erase the rest of the stuff, because we don't need these now. Thank you for your patience. Okay, cool. Now we go. So we're going to say now sec. What is sec? Sec we know. I can just simply come back. Okay, tan we know, because tan equal to x over square root of 2. So tan we know we sorted, and this tan we know we sorted. So the problem is only sec. So I can get the sec from trig identity. Look, I know sine square plus cos square. You know, I can just do from the head, but I'm showing this for you to remember, right? Cos square equal to 1. How do I get sec? We know for fact sec equal to, how do you get sec? Sec is 1 over cos. So divided by cos throughout. If you divide by cos throughout, it's going to be divided by cos throughout, divided by cos throughout, divided by cos throughout. Why? Because I don't want to get sec here. So this is going to give us sec, and then equal, this is going to be 1, and then plus, this is going to be tan square. Oh! So if I want to get sec, but this is like sec, it doesn't have a square. Sec equal to square root of this, square root and square root. So sec equal to, I can just remove, okay, square, right? So square root and square root. So I can just simply this and this cancel. So sec equal to square root of tan square plus 1, because I have my 10 already. So equal to tan square plus 1. So this equal to tan square plus 1. So then sec theta equal to, what is my tan? My tan square, I know it, tan square. This is equal to this one. So what is tan? Tan is like x over 2. Look, tan, look, let me look at right here. Look. See this one here? Tan theta, I can say tan theta equal to x over square root of 2. So tan square means it's going to be square of this and square of this, which is going to be x square over 2. So tan square is going to be x square over 2 and the plus 1. This is sec and our tan equal to that. So I can take this value and plug in here and finish up the question, because the question they did give us in terms of x's, they didn't give us in terms of theta, theta, theta. So finally, okay, sec, we know about sec. Sec equal to that one. So I will say, instead of sec, I'll say square root x square over 2 plus 1. Now we go tan. What is a tan? A tan theta equal to x over square root of 2. X over square root of 2. So multiply by x over square root of 2. You see what I'm saying? And then this you can multiply with x times. I can just write hey, x here. Okay. Okay, I can just simply say. Oh, you can write like that, or you can start with this first. Either the two. Or I can write x square root of 2 first. X square root of 2 first. Either of the two. Minus minus. So write minus here. Now we go ln. Absolute, absolute. Sec of x, what is the sec of x? This one here. X squared over 2 plus 1, but what? Square root plus tan. What is your tan? Our tan equal to x square root of 2. See what I'm saying? X square root of 2. And then, that's all. If I want, let me see if I can put them together in any way. No, that's all. So that's what you can do for now. Or you can say, oh no, hold on. This one, no, it's gonna stop here. Look, sec. What is sec? Sec stop here, and then so ln, and then absolute sec. What is x? Sec is this one, x squared over 2 plus 1, and the plus tan. What is a tan? Tan equal to 1 x over square root of 2. See what I'm saying? So yeah, just like that. Or if you want to pull this together, you can too, just in case. So you could have say, you can live like that if you want, and that's it. Or if you want to do something extra, then you can say x over square root of 2, and then this is x squared over 2 plus 1, and then minus. Look, this has a square root 2 and this has a square, so I can put them together, say ln, and then I can say the numerator, this is absolute, right? Numerator is x squared plus 1 plus x, but denominator, look, if you separate this, means it's going to be, look, square root of x squared plus 1 and square root of 2. So the denominator is going to be common here, square root of 2 for both. Because this is going to be have a root and this have a root. So I can write like that if you want. So we can simplify a little bit further here. Look, I can find the common denominator. These 2 is going to come here, and these 2 times it's going to become 2, and this times then it's going to be a single denominator. 2 times it's going to be, look, it's going to become 2 and then over 2. Let's write like this. See what I'm saying? It's like multiply is going to give you 2, and then this is like over 1 times equal to x squared over square root of 2. Here, probably I can just leave it how it was before, or like this, however you prefer. See? Okay, but remember, now you can separate here. Say this same as, you can say, okay, look, this is like square root of the top one, square root of the denominator. So I can just say, look, if somebody gives square root of a over b, single square root, this time say square root of a, square root of b. So for that case now, I can just say square root of the top one and square root of the denominator, which is going to be like this. When you multiply this, it's going to give you 2. So this is going to be x over 2. So all this is going to be x over minus. Okay? And then I can say absolute ln of absolute See, ln of absolute. And then I'm just trying to play around here. These 2 times can become 2, and this like 1. 1 times x squared equal to x squared over square root of 2. See, so these 2 is for both. So since it's for both, let me do this. Excuse me. Let me do this. Okay. Now I can rewrite this as, look, I'm gonna say 2 times 1 equal to 2. 1 times x squared equal to x squared plus. See. And then I can say all of this over 2. And then we have a root here for both. And then here plus x over square root over 2. So plus your c. Don't forget to plus your constant because we don't have no limit. If you don't have no limits, make sure you plus your constant. So all this answer and then plus the constant. I can just plus here. Okay, let me just say plus c. Plus c. That's how we do. That's how you do.